Nemotron 4 billion versus Qwen. Or is it Qwen versus Qwen? Last days I see a lot of articles writing that Nemotron is Qwen, and let's clarify it before we dive into stress test encoding. If we ask the model itself, it's answering that it is, after thinking, of course, and saying about the policies that it has, that it cannot tell everything, etc. This says that it is Qwen, the model of Alibaba. Okay, that is not true. A lot of times models don't know what exactly they are. That is not the first time. And what exactly happened here is that NVIDIA designed Nemotrons from the scratch with the new architecture, like we said in the video before. But NVIDIA used Qwen to train his models that he just created. She created this Mambo architecture with long contents and all benefits that we saw, and she used the Qwen model with 30 billion parameters to train all the family of the Nemotron. That is maybe that reason that the model answers that it is Qwen. It had a lot of time with Qwen. Now that we clarified that, let's proceed to some more details. Here you see the Nemotron 9 billion. From that our model comes, and from that model with elastic compression, a technology of NVIDIA that is very powerful and can compress the model so he don't loses much of his power. So we have here the 4 billion model that is in a lot of tasks, not in all, of course, because it's the half of the model from that it comes, but in a lot of tasks it's very close to the 9 billion Nemotron, and that is very, very good for us so we can run it in small devices and have a powerful model. And for NVIDIA it's cheaper because the company don't need to train a model with this procedure. And the result is that we have a 3.3 faster model than its Qwen competitor. Okay, let's make it more interesting and push both of the models and their limits. Let's make some coding tasks and see how their models are doing. Of course, they are not for coding complex tasks because they are 4 billion, but for more simpler scripts it's more than enough. But in this case we're gonna try to push them a little more, and so we're gonna ask them something that is a little more complex and has to do with math too. A simple tracker for our budget that is written on Python. The user can log what he buys, coffee, restaurants, all those expenses, with a category and the amount and the date. And until yet, it's very easy. Now we make it a little more difficult. The app must track a monthly budget limit per category and warn if the user hits 18%. It must calculate the spending average, so a little math here, and predict if you will overspend by end of the month. So we add this prediction too, so I must calculate a little more. Based on the current habits, detect suspicious patterns. Here a lot more calculations. Like you spent 3 times more on coffee this week than your weekly average. This needs a little more thinking to get done. And print a clean weekly summary. Okay, and if the user logs the same type of expense more than 2 times a day, it should be flagged as a habit. Both models are thinking here, and it's very interesting how they think. And the left we see Qwen, and on the right we see the NVIDIA Nemotron. Okay, it's here we see exactly how the models think. They both are getting ready with a project plan. They're writing down exactly what must be created. Go and count all the steps that be done until 7, and then more analytic how we can implement all these features. Both models have the reasoning, thinking mode, so that helps to get much better results than other models, because they are planning now, they're calculating all the options that they have, and after the planning they know exactly what must be considered most, what must be done, and how it is done better. With the thinking mode helps a lot on that point. We see that Nemotron is already writing the code, and Qwen is still planning and thinking. Nemotron has written already 1 page of code, and the code is very nice structured, I must say, with a lot of comments, and I saw that it started with commenting what exactly the app does inside the code, and in every part that Nemotron completes, he writes a headline like public API, record transaction. So somebody who reads the code can find exactly what the code does. Okay, Qwen still thinks here. This tests run on Ultra 7 165U. So you can have an idea of how fast the models are, and more details if we see the token per second. I run this on the CPU for this test. We're going to speed this up because it's gonna take a long of time, longer than I expected, and maybe the task was a little too difficult, but I wanted something that can hit their limits, so we can compare better. We see that Nemotron is already finishing, and he finished the code, and he's writing what the script does in a table at the ending. Okay, all the steps that Nemotron implemented, and we see that Qwen is still thinking, and so we're gonna go a little later and write in the table what we got. Okay, Nemotron was a lot faster. We got 5.7 tokens per second, this task. And it took a lot of time, but not so much that Qwen took. 13 minutes and 52 seconds to write all this Python script, this little application. Okay, and I saw he make it some suggestions that we can make a UI to combine it, and some others too. Qwen is ready to complete. It's on the last steps, writing the output. Both created some example data, so that we can test them already. Qwen was not so good in the commenting of the script, so it's not so good readable for a human. The speed was 4.18 token per second, and the time is 8 seconds and 8 minutes and 6. Okay, that is not true because we must include the thinking time, and then it's a lot more because we come in. Okay, here we see the code output side by side. On the left side we see Qwen, and on the right we see Nemotron. Nemotron's code is more easy to read, like we said. The comments in the begin explaining what exactly is done by this code, and it's very nice organized. If you code, you know that is very good structured. And now to the final results. Okay, I need to say that both models failed to run the script. I got errors in both scripts because I wanted to try them. They both fixed the code after more tries. Here we have the table. We saw the speed, 5.7 for Nemotron, and Qwen is a little slower with 4.18. Okay, Nemotron was 36% faster, and this is from the architecture, like we said. The task completed in 12 minutes and 44 seconds for Nemotron, and Qwen took 37 minutes and 46 seconds. That is a lot more. He needed much more time to plan the script and the thinking, and then he executed faster. But the thinking was very detailed, and Qwen lost a lot of time there. The lines. Now we got 303.1 lines with Nemotron and 217 lines with Qwen. That don't means that Nemotron has written the same result with more lines. No, that was the documentation that make it look larger. Okay. I saw the code by myself, and then I really tested it and inspected it, with Cloud Code to make it faster. And the bugs was the same. Nemotron had one bug more, but was in the fixing faster. It had a logic error, and that was a little disappointing in the name of a function. The function was isHabit, and sometimes his routing is hetip, and that was a little bad, but okay. In general, both models performed good for 4 billion models. Nemotron shows his strength with the time, and he take advantage of the fast execution in many tasks. I hope you like it, this more detailed test. And of course, the bigger models are more usable for coding. The 32 billion Nemotron. Qwen has a model for code too, and it's optimized for coding a little more. That I need to mention here. We definitely hit their limits for 4 billion. If I make it a little easier, that would done the job a lot better. That's all for today. I hope you liked it. Subscribe to see us destroy more models and pushing them to their limits.